Let a continuous random variable x denote the diameter of a hole drilled in a sheet metal. The target diameter is 12.5 millimeters. Most random disturbances to the process result in a larger diameters. Historical data show that the distribution of x can be modeled by a probability density function of f of x equals 20 times e raised to negative 20 times x minus 12.5 for x greater than or equal 12.5. If a part with a diameter between 12.5 to 12.6 millimeters is scrapped, what proportion or probability of parts is scrapped? Hi everyone, this is Eric Guzman and welcome back to my YouTube channel. For today's video, we are going to discuss a topic from statistics and probability, the continuous probability distribution. So without further ado, let's begin. When a random variable x is discrete, you can assign a positive probability to each value that x can take and get the probability distribution for x. So the sum of all the probabilities associated with the different values of x is equal to 1. However, hindi lahat ng experiments result in random variables are discrete random variables. That's why meron tayong tinatawag na continuous random variable. So paano ba natin masasabi na ang random variable x is a continuous random variable? It is a continuous random variable if number 1, its possible values comprise either a single interval on the number line for some a less than b, any number x between a and b is a possible value, or a union of disjoint intervals. Number 2, if the probability of x say equals to c is equal to 0 for any number c that is a possible value of x. Continuous random variable is a random variable with an interval, either finite or infinite, of real numbers for its range. So the model provides for any precision in length measurements such as heights, weights, length of a life of a particular product, or pwedeng experimental laboratory error. So it can assume the infinitely many values corresponding to points on a line interval. Gagamit tayo ng different approach to generate the probability distribution for continuous random variables. Yung depth or yung density of the probability which varies with the random variable x may be described by a mathematical formula. Again, like the discrete, gagamitin din natin dito yung f of x, and it is called as the probability distribution nga, or the continuous probability distribution, or probability density function for the random variable x. Yung probability density function na yan provides a simple description of the probabilities associated with the random variable. And it is 0 for x values that cannot occur, and it is assumed to be 0 whenever it is not specifically defined. So, nagagamit again natin yung histogram because histogram is an approximation to a probability density function. The graphical form for the continuous probability distribution can be represented by a smooth curve. So, ang histogram ng variable, again, a smooth curve. So, pag sinundan natin ng line yung bawat top ng bar sa histogram na yan, so ayan. For each interval of the histogram, the area of the bar equals the relative frequency, or tinatawag natin as the proportion of the measurements in the interval. Relative frequency is an estimate of the probability that a measurement falls in the interval. Similarly, yung area under f of x n over any interval equals the true probability that a measurement falls in the interval. Ang important point natin sa continuous probability is that yung f of x is used to calculate an area that represents the probability that x assumes in a value. The probability distribution of f of x, say yung probability of a less than x less than b is equal to the shaded area under the curve. Ang limits natin is yung a and yung b natin, at itong shaded area na yan sa yung probability distribution. For a continuous random variable x, a probability density function is a function such that it follows these three requirements. Yung probability density function natin, or yung continuous probability distribution, is either greater than or equal to 0, and from the limits infinity, negative, and positive infinity, yung probability distribution natin ay nagsasum into 1. And if we are given a values for some random variables natin, again, parang yung smooth curve natin kanina, yung area under dun is the probability. If x is a continuous random variable for any x sub 1 and x sub 2, then this is our equation. Example number 1. Let a continuous random variable x denote the current measured in a wire in milliamperes. So assume that the range of x is from 4.9 to 5.1 milliamperes. And assume the probability density function of x is f of x equals 5 for 4.9 less than or equal x less than or equal 5.1. Question: what is the probability that a current measurement is less than 5 milliamperes? So for the probability, x less than 5, so this is the probability that the current measurement is less than 5 milliamperes. So this is our graph. At ito yung ating f of x, of course, and this is the random variable value na x. Ang value ng f of x natin is 5. So this is 5. And we have two limits from 4.9 to 5.1. Yan yung values ng random variable x natin. From 4.9 to 5.1. So ito yan. This is the probability na 5. So again, in the condition, f of x is equal to 5 for 4.9 less than or equal x less than or equal 5.1. So let's take this mid. And this is the shaded area. The probability density function is makikita natin dito sa histogram na ito, and it is assumed that yung f of x is equal to 0 wherever it is not specifically defined. So yung shaded area natin indicates the probability. Therefore, yung probability that x is less than 5 is equal to this formula, f of x dx from a to b, where ang a natin is ito. And ang magiging b natin, since the condition is less than 5, so 5 ang ilalagay natin sa b dito. Ito kasi yan. Substituting the values, integral of f of x natin is 5 dx from a natin na 4.9 to 5. And calculating probability of x less than 5, or the probability that the current measurement is less than 5 milliamperes is equal to 0.5. So we have a 50% probability. And this is example number 1. Example number 2. Let a continuous random variable x denote the diameter of a hole drilled in a sheet metal. The target diameter is 12.5 millimeters. Most random disturbances to the process result in a larger diameters. Historical data show that the distribution of x can be modeled by a probability density function of f of x equals 20 times e raised to negative 20 times x minus 12.5 for x less than or for x greater than or equal 12.5. If a part with a diameter between 12.5 to 12.6 millimeters is scrapped, what proportion or probability of parts is scrapped? So let's draw first the graph. This is the f of x, and this is the random variable x. Again, the question, if a part with a diameter between 12.5, this is the 12.5 millimeters, and this is the 12.6 millimeters. So, wala tayong exact value ng probability density function like example number 1. So, possibly, this is the graph, and 12.5 here, 12.56 here. Again, the probability of parts scrapped between 12.5 to 12.6. Ito yung area na yan. Therefore, yung area na yan yung magre-represent nung parts na scrap. So, this is probability of 12.5 less than x less than 12.6. And this is equal to the integral of f of x dx from a to b, where ang a natin is the 12.5 and this is the b natin, the second limit. Substituting the values, this is the integral of ang f of x natin is 20 times e raised to negative 20 times x minus 12.5 from 12.5 to 12.6 dx. So, calculating the value, probability of 12.5 less than x less than 12.6, or the probability of parts scrap with a diameter between 12.5 to 12.6 millimeters is equal to 0.865. So this is example number 2.